Section 2.7, example 6, solving an inequality with fractions. Ooh. So the following inequality and write the answer in interval notation. All right, so it's not too scary because we don't have any variables in the denominator. They're all in the numerator. From here, just like we did in the like earlier sections, I can't remember exactly which one it was, but earlier sections, in order to solve these problems, we have to multiply by what we call the LCD. So leading common denominator. So a number that's big enough to be divided by 4, 8, and 3. We'll start off with 4. So 4 divided by 4 is equal to 1, which cracks that fraction. What about 8? 4 divided by 8 is equal to 1/2. So we have to multiply this by 2 in order for it to be divisible by 8. So 4 times 2 is 8, divided by 8 is 1. We crack the fractions there, but what about 3? 4 times 2 is 8. 8 divided by 3 is still 8 divided by 3. So now we have to multiply this value by 3. What is that? 12, 24. 24 divided by 3 gives us 8. Fractions cracked there too. So it looks like we found our value. So 4 divided by 4. Good. Our number divided by 8. Good. Our number divided by 3. Good. So our LCD in this case is going to be 4 times 2 is 8, times 3 is 24. So multiplying both the left side and the right side by 24. And hopefully that makes it a little bit easier for us to solve. So rewriting this, we have -3 over 4x greater than or equal to -5 over 8 plus 2 over 3x. And we're multiplying both sides by our LCD, 24. And that leaves us with 24 divided by 4. The 4 divides out and we're left with 6. So we have 6 times -3x greater than or equal to here. 24 divided by 8 goes in 3 times. So we have -5 times 3. Plus here we have 24 times 2 over 3. 3 divides out with 24 8 times. So we have 2x times 8. And let's distribute and simplify. So 16 times -3 is going to be a -18x is greater than or equal to -5 times 3 is a -15. And 2x times 8 is 16x. Now we want all of the variables over to the left side, so that way we could solve for the variables. So moving this value over to the left side, subtract both sides by 16x. And that leaves us with a negative. Again, we're just adding. Well, in this case, subtracting. We're not multiplying just yet. So we leave the sign just the way it is for right now. That's 4. So we have -34x greater than or equal to a -15. And now to get x by itself, we have to divide by a -34. Divide by -34. Now that we're dividing by a negative number, now we could switch the sign. So we end up with x instead of greater than or equal to, now we have less than or equal to. Negative divided by a negative is now positive. 15 is made up of 3 times 5. 34 is not divisible by 3, nor is it divisible by 5. So we call these two values relatively prime. So it would just be 15 over 34. Let's throw this on a number line to see what our solution is in interval notation, because they did ask for interval notation up here. So negative or positive 15 over 34. X is less than 15 over 34. So we're looking at values that are smaller. So we're going to move over here to the left side. Less than or equal to indicates a closed circle. So we're going to close that up. And now interval notation. So starting off with the left side, we go to that left pointing arrow indicating negative infinity. And on the right bound, we have 15 over 34. Closed circle indicating that we do include that point. Bracket also indicating that we include that point. And that's it. That's our solution. If you have any questions, please feel free to ask. Otherwise, bye.